All right, guys, make sure that you have a packet of notes before we get started. Just some reminders so you can make sure that you're not forgetting anything coming up. First thing you need to remember is that our online homework is due tomorrow. The next thing, labs are going to be due tomorrow. And then our snow globe project is due Wednesday. Remember, it's a major grade. All right, guys, we're about to go over the test review for tomorrow. Things that you can expect to see on the test, guys. It's our normal. We're going to have it's going to be multiple choice. There's 31 questions, and the review is a very, very good study guide for this. What we're about to go over. So make sure that we're studying that. One thing that I would recommend, kind of making note cards for this because there's going to be a lot of vocab on the test. So make sure that we do that. Tomorrow, make sure that we're bringing a calculator. Remember, we don't have calculators, so make sure to bring your own so you can take it on the test tomorrow. I will be here early on Friday morning, so come and see me if you have any questions. But guys, again, it's a lot of vocab. Make sure you're spending some time on it, memorize it, get it done so that you get a good grade. Okay, guys, let's go ahead and start talking about your test review. This will be the test that you'll take over solutions and acids and bases. Now, first of all, starting off with solution formation. Some factors in determining the rate of solution, the rate meaning if it's going fast or if it's going slow, meaning is the solute dissolving faster or is it dissolving slower in the solvent. Things that we can do to increase it. It can be stirred or shaken, meaning we can agitate it. Particles are made smaller, so if we take them from bigger to smaller, and the temperature increases. Okay, what's happening when we're looking at agitation? We're seeing that we're moving that solute around. When we're breaking it up into smaller particles, we are increasing the surface area. And when the temperature increases, that means they're moving around faster. They're bumping into each other, the solute and the solvent, a little bit more. Now, in order to dissolve, the solvent molecules have to come in contact with the solute. So we see other things that can help us is stirring, which moves fresh solvent next to the solute. Okay, the solvent touches the surface of the solute, and therefore it gets dissolved. Now, we also make smaller pieces, which increases the amount of surface area being the key word here, of the solute. So the more sides to it, more sides where the solvent can touch it. Anytime that it touches it, it allows it to be dissolved. Now, when we look at temperature, higher temperatures makes the molecules of the solvent move around faster and contact the solute harder and more often. So this allows the rate of the solution dissolving to speed up. Okay, it usually increases the amount that also can be dissolved, but this is an exception with gases. Remember that in gases it's the exact opposite. If we increase the temperature, we actually decrease the solubility. Okay, if we decrease the temperature, then we increase the solubility. Remember that type of a relationship where one goes up, the other goes down, we see that it's an inverse proportionality. As temperature goes up, solubility in gases go down, and as temperature goes down, solubility in gases goes up. Now, when we're talking about solubility, the main unit that which we use, solubility, guys, we need to know all four of these definitions. You will see these on your test. Okay, the solubility is the maximum amount of substance that will dissolve at a specific temperature. The units we usually have for that are grams of solute per 100 grams of solvent. Okay, and we see that if we get to that maximum amount, and the solution contains the maximum amount of solute that it can be dissolved, we see that that's a saturated solution. We cannot put more in there at that certain temperature. Okay, unsaturated solutions, we can still dissolve more of the solute. We haven't reached that maximum yet. We haven't gotten there So basically, a saturated solution is the maximum. The unsaturated solution is anything less than saturated, anything less than the maximum. And then lastly, we have supersaturated solutions. And supersaturated solutions is a solution is holding more than theoretically it should be able to hold. So it's even higher than the saturated solution. We have more than is saturated, so it's supersaturated. Um, and we see that when this does happen, we usually have to increase the temperature very, very, very high to get a supersaturated solution. Now, we've talked a little bit about like dissolves like, especially when looking at our snow globe project. And the main thing that we said about it, we said that polar solutes are dissolved in polar solvents. And when we're looking at polarity, remember that polarity means that we have a positive end and we have a negative end. Okay, so if it's polar and it's the solute's polar, it can be dissolved in a polar solvent. But a nonpolar solute can only be dissolved in a nonpolar solvent. And this is where we get it in our snow globe project. And we saw that we have to get a polar solute and a nonpolar solvent, and if we put them together, they will not dissolve each other, or the solute won't be dissolved in the solvent, and so therefore it gets that snow globe effect, and you can actually see the particles inside of the solvent. Now, remember, looking at solution formation, main thing here, when we're looking at it, make sure that the particles that are involved in solvation, which that is the forming of a solution, the particles involved are always the solute and the solvent. And the solute and solvent really tell us whether a substance will be dissolved, and also tell us how much can be dissolved. And remember, the solute always is dissolved in the solvent. The solute is always added to the solvent. Okay, so if we see in the question, solute is added to solvent. So if we see that potassium is added to water, we know that the solute is potassium, the solvent is H2O. Now, looking at gases and liquids, we've already talked about them a little bit, and we said that if we increase the temperature, we decrease the solubility of gases and liquids. And we also have a law, and we said that Henry's law says that the solubility of a gas in a liquid is directly proportional to the pressure. So the main thing here, we're dealing with pressure now, and we're looking at pressure of a gas above the liquid. So if they're directly proportional, that means that as one goes up, the other goes up. So if pressure goes up, then we see that the solubility goes up. If pressure goes down, solubility goes down. And this is where we talked about a can of Coke or a bottle of Coke. We said that the Coke companies, so that they can make the Coke stay, have carbonation in it, and so it doesn't go flat, they put that carbon dioxide in the Coke at a very, very high pressure. And that's why when we open up a bottle of Coke that it makes that sound and we hear the carbon dioxide released. Okay? They put a lot of pressure on it so that they can put more CO2 in that Coke so that it doesn't go flat. Now, let's go ahead and let's look at a molarity question. Now, remember, molarity has to deal with specifically concentration. We're looking at the concentrations of solutions. Okay? And the equation for molarity, we always need to know this. The equation is always going to be molarity, which is the big M, equals moles of our solute over liters of solvent. Okay, so this is our equation that we have. So whenever it talks about molarity, we always need to write down that equation so that we can make sure we're knowing what we're solving for. Now it says, what is the molarity? So obviously our unknown is going to be molarity. It says, of a solution that contains, we have 0.903 moles of potassium chloride and 4.98 liters of solution. Okay, so to set this up, all we have to do is go ahead and put our 0.903 moles on top, and then we put our liters of solution. So we put our 4.98 liters of solution. We go ahead and we plug that in a calculator, and we see that we would get an answer of right around 0.183, and remember it's a capital M for molarity. Alright guys, let's move on to the next one. Now here you can see that we're changing it and working with molality. Now main thing here, molality has a different equation. We have a lowercase m equals our moles of our solute all over our kilograms of our solvent. Okay, so let's look and see what the problem's asking us for. It says, what is the molality? So it's asking for molality, lowercase m, of a solution that contains, and it gives us 8.10 moles of potassium nitrate in 7.47 kilograms of water. Okay, so here we have our moles, we have our kilograms. All we have to do is plug it in, put our moles on top, which is going to be 8.10 moles, and that's of potassium nitrate, all over our kilograms of our solvent, which is 7.47 kilograms of water. And we go ahead and we plug this into a calculator, and we see that we get an answer of right around 1.084, and that would be molality, which is a lowercase m. Alright guys, moving on to the next one. Now here again it says what is molarity, so we know we're going to be using the molarity equation. Remember that it is moles all over liters. Okay, it says what is the molarity, so we're searching for capital M of a solution that contains, gives us 138 grams of NaCl and gives us 9 liters of solution. We know that liters of solution is going to go on the bottom, so the other thing we need to solve for molarity is moles. So we have to change our 138 grams into moles. Now to do that, we start off with 138 grams of NaCl, and we have to find the molar mass of NaCl. So we look in the periodic table and we see that sodium weighs 22.99, and there's only one of them, so it just weighs that. And chlorine has a mass of 35.45. And we add those two things up and we see that we get 58.44 grams. Now that means grams per mole. So I know that 1 mole of NaCl equals 58.44 grams of NaCl. So I put grams on the bottom, 58.44 grams equals 1 mole. And all I'm going to end up doing is dividing by our molar mass, and we get 2.36 moles of NaCl. Okay, so now we have our moles, we have our liters, all we have to do is plug it into the equation. Molarity equals our moles, which is 2.36, all divided by our liters of 9.00, and we should get a molarity of right around 0.26, and that would be a capital M. Now in the next one it says, what is the molality of a solution that contains 67.0 grams of HCl in 7 kilograms of water? Well, we know that molality is lowercase m equals our moles all over our kilograms of our solvent. Okay, so all we do here is we have to figure out, since we have our kilograms, we're finding molality, we need to find moles. So we have to do the exact same thing. So we're going to end up dividing by the molar mass again. So we have 67.0 grams of HCl, which is hydrochloric acid. And we have hydrogen is 1.01, chlorine is 35.45, which would give us a molar mass of 36.46. So we put that on the bottom, we get our 36.46, and it equals 1 mole. We divide that on out, and we should get right around 1.84 moles of hydrochloric acid. Now, from here, we go ahead and plug into our equation. Molality equals our 1.84 moles, all divided by our 7.0 kilograms, and we would get a molality of 0.263, and that would be a lowercase m. Now, moving on, and we're going to move on to talk about the properties of acids and bases. Now, main thing here, guys, remember that acids are going to taste sour, okay? They're going to have a sour taste to them, so anything that you eat that has a sour taste to it, lemon juice, any type of sour candy, that's what's happening is you have an acid, okay? We know that they conduct electricity and that they are strong acids or strong electrolytes, weak acids or weak electrolytes. Remember, electrolytes just mean that they conduct electricity. They react with metals to form hydrogen gas. We know that in our labs that we've done that with our indicators, with our blue litmus paper, if the blue litmus paper turned red, we're dealing with an acid. It reacts with hydroxide to form water and salt. Big ones here: taste sour, change our blue litmus to red. Okay. Now, properties of bases. They react with acids to form water and salt. Main thing here, they taste bitter. They feel slippery. Again, they can be strong or weak electrolytes. They can conduct electricity. But main thing here, taste bitter and turns red litmus paper to blue. We saw this in the lab. Red to blue, we know it's a base. Now, we talked about a couple different theories of acids and bases. One main theory that we focused on was the Bronsted-Lowry definition of an acid and a base. Got to know the definition of it. Acid would be that it donates a proton, specifically a hydrogen. Okay, we said that if the hydrogens go down, we know that it's an acid. If our hydrogens go up, we know that it's a base. Okay, and we see that a base is a proton acceptor, meaning it's going to gain our hydrogens. Goes up, it's a base; down, it's an acid. Now, we also talked about conjugate acids and conjugate bases. Now, we said that acids will make conjugate bases and bases will make conjugate acids. Now, the formal definition is what is left over after an acid gets rid of its hydrogen, and a conjugate acid is the product that gains the hydrogen from the original acid. So remember, we're talking about on a chemical equations. The acids will always make our conjugate bases, and our bases will always make our conjugate acids. Okay, we're looking at our a chemical equation when we look at those. The other theory that we talked about Lewis acids and Lewis bases. Main thing here, Lewis acids, they are electron pair acceptors, and Lewis bases are electron pair donors. Okay, Lewis acid, electron pair acceptors, they accept, and we're mainly dealing with electrons here. Lewis bases, we are dealing with donors, and we're dealing with electron donors. Guys, main thing here, looking back, protons for the Bronsted-Lowry definition, the base or Lewis acids and Lewis bases, we're dealing with electrons. And guys, remember that the Lewis acid, Lewis base is the broadest of the three definitions. Okay, it's the broadest. It covers the most things. Now, here in this question, it says in the reaction we have hydrofluoric acid plus our water equals our hydroxide and our fluorine ion. So when we write it out, we want to know what's acid, what's a base, what's a conjugate acid, conjugate base. So we have our HF plus our H2O, and it produces our hydronium and our fluorine ion. And we're looking at our definition of our Bronsted-Lowry definition, and we go from one hydrogen to no hydrogens. Okay, so we see that it donated it, our hydrogens went down, this is going to be our acid. Okay, we look at our water. It went from 2 to now it has 3. So it gained a hydrogen, so it's a base. We always know that acids make conjugate bases and bases make conjugate acids. So the HF and the fluorine ion would be a conjugate acid-base pair, and then our water and our hydronium would be a conjugate acid-base pair. All right, moving on to the next question, we have H2SO4 plus our H2O produces, we see we have a hydronium ion again, and then we have hydrogen sulfate. Now here again we look and we see that we go from 2 to only 1. Okay, so we went down, so here's going to be our acid. That makes this our conjugate base. And with our water we go from 2 to 3, so we go up, so this is going to be our base and this is going to be our conjugate acid. And in this reaction we have NH3, which is ammonia, plus our H2O, and we see that it produces a hydroxide ion and our ammonium ion, and we see that we go from 3 hydrogens to 4 hydrogens, so therefore it went up in our hydrogens. So here we have a base and we go from 2 hydrogens in the water to only 1 hydrogen in our hydroxide, so this is going to be our acid. We know that acids make conjugate bases and bases make conjugate acids. Alright guys, that's it for your review. Make sure that we're paying attention and doing as much as we can. Make sure to finish up your homework for tomorrow. Everything's due on Friday. Our labs are due on Friday. Our homework's due on Friday. Alright guys.